Hey there, geometry people. Today we're doing 1.3 part 2. So yesterday we did part 1. It was all about midpoints and finding the midpoint, or using the midpoint and an endpoint to find another endpoint. Today is all about the distance formula and bisectors. So we want to be able to, by the end of this, identify a segment bisector and use it to find missing lengths. And we also want to use the distance formula to find the distance between 2 points. So here we go. First, we're going to talk about segment bisectors. Segment bisectors. Okay, so a segment bisector is a point, line, or ray that cuts a segment into 2 equal pieces. So it divides it in half, basically. So for example, let's say I have this segment here. And we have a ray, and we'll call this segment RS and ray QP. Okay, so there's some notation around bisectors and congruence that we want to talk about. So whenever you see a line like that in the middle of a segment, that means that it's congruent, or the same length, as any other segment with one line just like that. So if I have 2 lines like this, one here and one here, that means that these are 2 equal pieces. So that shows congruence. So that's some notation there. It shows us that those are the same length. You could also see that, if this was if they were both labeled as being 3 units long, that would be another clue that this is being cut into 2 equal pieces. Anyway, if you were to be asked what is the bisector of segment RS, you would say the bisector of RS is ray QP. So if you were asked what is the bisector, QP is the bisector. Okay, so now we can identify a bisector maybe, but we need to be able to use them to find missing information. So here's another example for us. Let's say we've got another segment AC, and point B is a bisector. So B is the bisector of AC. And if at any point this is going too fast, feel free to pause it and catch up if you're taking notes at the same time. Okay, but B is the bisector of AC, and let's say we know that AB is 5 units long. A question you might be asked is, how long is AC? Or what is AC? Because this just means the length of AC, right? Well, AC is the whole thing. So if B is a bisector and we know that AB is 5, that means that BC is also 5. So then the whole entire thing, AC, would be 5 plus 5, which is 10. You could also just take the 5 and multiply it by 2, since you know that this is half, right? Either way you want to think about it is fine, but our answer would be 10. Okay, so that's pretty much everything about bisectors that we need to know for now. The next thing we need to talk about today is the distance formula. So moving along to the distance formula. Okay, So the distance formula will help us to be able to find the distance between 2 points. Okay, so the distance between 2 points, we'll call them x1, y1, and x2, y2, is given by the formula d for distance equals big square root. Parentheses, we have x2 minus x1 squared plus y2 minus y1 squared. Okay. So if I have 2 points, I can plug them into this formula, and that will tell me the distance. So let's do an example of that. Let's say we're given point A is -3, 4, and point B is 2, 1. Okay, so the first thing that you want to do is label your points. So what I mean by that is I'm going to label this one x1, y1, and I'm going to label my other one as x2, y2. Sorry, that's my dog growling. He wants to go home. Okay. Ender, come on, buddy. All right. So here we go. Anyway, sorry about that. Now what we want to do is plug these points into this formula. So I'm going to make my big square root. And here we go. You can even put in your parentheses and stuff ahead of time in your squares if you want to. So we set that up. And then we go x2, which was 2, minus x1, which was -3. So we go minus -3. And then in the other set of parentheses, we have y2 minus y1. So we go y2, which is 1, minus y1, which is 4. Okay, so now all we have to do is simplify this. Okay, so what we have to be careful with though is when we simplify, we want to make sure that we do our subtracting and our adding and our squaring all correctly. So if you need to use a calculator, please do, because it will save you a lot of trouble in the long run. Okay, other than that, let's get going with our simplifying here. Remember, anytime you subtract a negative, that's like adding a positive. So really what we've got here is 2 plus 3, which is 5. So I'm going to bring out another square root. And now we know that this is 5 squared. And 1 minus 4 is -3. So we have -3 squared. Now the important part here when we continue simplifying is that when you go to put -3 squared into your calculator, unless you already know what it is, make sure you put parentheses out around the -3 and then put the square on the outside. Otherwise, it will tell you that it's a negative number. But anytime you square something, it is always, always, always a positive number. So, or you can just think of it as -3 times -3, which is +9. And then 5 squared is 25, since it's just 5 times 5. Okay. And then 25 plus 9 is 34. We got to keep our square root hanging out there. And then, if you are asked for something in exact form, that means you want to leave it with the square root, unless it's something that square roots nicely. Some numbers square root nicely, like 36 is a perfect square. So if I did 36, if I had the square root of 36 at the end, I would want to just put in 6. But since the square root of 34 does not square root into something that's a whole number, if I wanted exact form, I would just leave it like that. But if I'm okay with having a decimal for my answer, then I can just say that it's approximately equal to, and then stick it into a calculator. So we can go like 5.83 or whatever you're asked to round to. This would be a rounded decimal. And that's all there is to it. So this would be our distance between those 2 points. Okay, let's do another one. This time we'll bring the calculator into it a step earlier if you want to. So if you are doing this and you have a calculator nearby, like a scientific calculator or something like that, you can type most of this into a calculator if you want to. So we'll walk through what that would look like as well. Although doing it by hand is a good way to make sure that that you know what you're doing, and it's good practice with simplifying. But anyway, this time we'll have point A be 3, -7, and point B will be 0, 4. And we want to find the distance between those 2 points. So we're going to do the same exact process that we did last time. First, we got to label our points. x1, y1, x2, y2. Then we got to get our big square root. And we can put our parentheses inside if we want to start us off. Then we have to go x2 minus x1. So in this case, it is 0 minus 3. And then in the second set of parentheses, we go y2 minus y1. So 4 minus -7. Okay, and at this point, if you would like to type exactly this entire thing into a calculator, that's actually something that will work. I'll show you on mine if you want to see how it would look, but feel free to simplify by hand as well. This one's a graphing calculator, but it works pretty much the same as your scientific calculator for things like this. Okay, so the first thing you would do is hit second and then square root. Then you want to start a set of parentheses and go 0 minus 3, then close your parentheses and hit the x squared button. Then you'd go plus, set of parentheses, 4 minus -7, close your parentheses, hit the square button. Once everything is typed in exactly the way it looks on your paper, you can hit enter, and it'll give you the answer. It'll give you a rounded decimal answer. In this case, it ends up being approximately 11.4. So you can do it that way if you like, or you can simplify by hand. Either way is totally fine, as long as you get the right answer. So we're going to go 0 minus 3. If we were simplifying by hand, that would be -3 squared. 4 minus -7 is like adding a positive. So that would give us 11 squared. So then we have to actually square those numbers. -3 squared is +9. 11 squared is 121. Adding those together, we get the square root of 130. So this would be our exact form of the answer. Either one is fine, but that's what we would do. So that would be our exact form. Okay, hopefully this was helpful for you guys. That's the entire lesson. We did distance formula. Just to recap, we can now find the distance between 2 points. And we can also identify segment bisectors. So if we remember back to our segment bisectors up here. And we can use segment bisectors to find missing lengths. So now it's your turn to go and practice. Have a wonderful day. I'll see you guys around.